In this example, we're going to see how to control user interface with code and how to make it react to events that appear in the world. Things like picking up a rupee. So look at the rupee counter in the top right. When I pick them up and when the character takes damage, we have some animation on the life bar that reacts to the character's health node being updated. So the character's health that you can see in the scene tree here gets updated when the character takes a hit, and the interface is in a remote part of our node tree. It doesn't directly get the value from the health node. We are using signals here to send the piece of information when the health changes to the UI, and then there's some code on the UI that's going to process it. We want to separate the interface from the characters. You don't want a change on the character. Say someday you don't want the health to work the same way, so you start to add statuses, you incorporate new variables and all those things. You don't want that to break your interface. And if the life bar was inside the character scene, this is bound to happen. So that's why you want to use signals to only send some pieces of information to the interface. It just receives the information and it can update based on it. Inside the interface scene on the life bar, we can get the new value and run some animation. That's what we're going to do in this demo. To get started, head to GitHub. The link is in the description. You will find the source code for the starting project so you can follow along. This tutorial is part of a series to learn how to design interface, and this GUI. You can look at the previous tutorial about interface design in Godot. Now we have all the objects set up for the character to pick up. And if I play the start demo, you do get this little widget to pick up items, and you can pick them up. But there's no code on the interface. The rupee counter will not update. If I press X to simulate damage on the character, its health changes on the player scene, but the life bar doesn't update. So that's what we're going to work on now. To start with, we're going to collect the information we need to get about the world. We want to know when a rupee gets picked up and when the character's health gets updated when it takes a hit. We're going to send these pieces of information to the interface. The interface is a scene that's instantiated in the demo scene, but it contains our life bar and the rupee counter. It will act as a funnel. The interface is going to receive the information and it's going to forward it just to the life bar in the case of losing health. And when the character picks up a rupee, it will send it to the rupee counter. To do that, we're going to connect signals from the player to the interface. So by default, the player is also a scene, and you won't be able to access the health change and the rupee count change signals on the purse. So you have to right-click on it and select Editable Children to access the child nodes in the scene. In order to connect the signals from the health and purse nodes we'll find there, we need to add a script to our interface. So let's do that. We're going to create an interface.gd script in the interface folder. You can use the empty template, so you don't have comments or anything inside of the script. And we're going to select the health node and connect the health change signal to the interface. Then we're going to do the same for the purse. We're going to connect rupee change to the interface. From there, we are going to send this data to the life bar that we have on the interface scene and the rupees to the counter. So let's open the interface scene, and we want to add scripts to the life bar and to the rupee counters as well so that we can forward the information. Let's do just that. Create the script. Because I'm using scenes, you can see when I add a script, it ends up in the right folder where those scenes come from. Now, I said the interface would act as a funnel. It receives information and it's going to forward the message. So we're going to create two signals to forward the health and the rupees to the life bar and rupee counter scenes. Let's create them at the start of the interface script. So health changed. And we're going to pass in the new health. And we'll call the other rupees changed. And we're going to pass in the new count. When the health changed callback method is called, we're going to emit the health change signal, and we're going to pass in the health. You can copy the line with Control C if you have nothing selected on the line, and paste it with Control V because we are going to use emit signal again. We just want to change health with rupees and the health variable name with count. As I added the script inside of the demo scene, it doesn't exist inside the interface scene. So let's head to the interface folder and drag and drop it here. Now I'm going to go to the node tab, change the selected node just so that the signals refresh. And we want to connect health change to our Lifebar, which has a script attached to it, right? So it's going to add the method to that script. And we also want to connect rupees change to the rupee counter. So we have the base setup where the information gets sent from the player to the interface and sent down to the Lifebar and rupee counter. Now, as we are on the rupee counter script, let's tackle this because it's the easiest one to do. The rupee counter scene has two nodes under the background element. There's an icon that's not going to change, but there's also the label named number. And when we update this rupee count, we want to change the text in that label. From the rupee counter script, we're going to get the number node and set its text to the count value. But as the count is an integer value, we need to convert it to a string. For that, we use the str function that's built into GDScript. And that is it for the rupee counter. The Lifebar is going to be a little more complex. We're going to enter the Lifebar scene because it will make it easier to work on the script and attach the Lifebar script to the Lifebar node. So we have to go to the interface folder, bar subfolder, where we have our Lifebar script stored. We attach the script and open the scene just so that when we use the dollar notation, we can get a list of all the nodes. If you don't have the scene open, you won't get autocompletion like that. So to start with, let us just update the health based on that callback. The Lifebar scene is a little more complex than the counter because we have a label on one side called number as well. And we have the texture progress, which has a range, minimum value, maximum value, and the actual value that sets the width of the texture. When I change it, you can see the texture update. We're going to update the texture progress's value and set it to our health value. Then we're going to get the number node under the count container, and we're going to update the text. So for this one, we want to set it as our health value divided by a maximum health, which we don't have just yet. Before we use the str function, now we're going to use string interpolation with a notation that's similar to what you found in Python 2. So you use the modulo sign followed by s to convert a value to a string. You add the modulo sign after your quotes, and you're going to add the value that you want to convert in here. The advantage of this method is that we can write other things inside of our string, and only the modulo s will catch a value that's after our quotes. So we can write something like modulo s / we're going to convert a second value after that. And when you have multiple values that you want to convert inside of your string, you have to use an array of values. You have to pass that. And we're going to pass a maximum value as the second parameter. Now we'll add that maximum value at the start of the script because it doesn't exist. And let's set it to an arbitrary integer for now. This will call the str function on the health and on the maximum value, and it will insert them in a string with 2 spaces and a / in the middle. And note I made a typo, so number is a label. It doesn't have a value member, but instead we want to assign this value to its text property. Let's try out the game to see that our character's HP is set to 18, so that is the actual HP on the character. out of a maximum of 20 that's hard-coded in the script for now. And if you go ahead and pick up rupees, you will see the rupee count update in the top right corner. Now we want to set the maximum on our life bar, and then we're going to animate it around the end of the tutorial. First, let us initialize our bar's maximum value. So to do that, we are going to use a method. We're going to add some initialize method or something like that will take a maximum and we will assign it to our maximum value. So we're going to store it. And then we will get the texture progress, so our bar. And in the range category, we will update its max value property. So it's max underscore value. We'll set it to this maximum value. We just store the maximum value on the life bar because we want to use the maximum value when we set the counts text, for now at least. Now we're going to initialize that value from the game. So we have to go back to the demo. Okay, we have a few options on how to get the actual value. We could use a signal from the health node at the start of the game, send it to the interface, and then funnel it down. But another way to do that is to get the value from the health node directly. So from the interface script, we're going to look at the player at the start of the game. And to get the player node, we're going to look into the node group called actors that the player is part of. So we're going to find the player in this group, and we're going to access its health node directly. That's one way to do it. In a small game, that's not too big of a deal. So you can, in general, you'll hear me say use signals whenever possible to keep things separate. But as the interface only relates to the player in this example, we can access the player directly at the start of the game. And if we need to, refactor that later. Now, in the ready function, we're going to get the nodes in the actors group. For node in, we need to get the tree first because get nodes in group is a method on the tree. And we pass in the name of the group that the node is part of. In this case, it's called actors. For each node in that group, we're going to check if the name of the node, so node.name, is player. We will have only one node that's called player in this case. So if the node's name is player, we can get the health node. So we're going to call get node on our player node in this case, and we can get the health node because we know that the player scene has one. We're going to store it in a variable that's outside the loop so we can access it after the loop. So let's call that health node. It's going to be empty to start with, and we'll store our health node in there, then break out of the loop because we found the node we were looking for. Once we have that piece of information, we want to get our life bar, and we're going to call the initialize method on it. We're going to pass in the health node maximum health. So that I call max underscore health. And you can check that from the health node, max health here. So this is going to initialize our bar, as I said. Also, because we have a signal emitted at the start of the game when we first set the health node's health, the life bar will also have the right starting health value. So you can play the game, and you will see our life bar and label are at 18 out of 18. If I press X, you will see the character lose some health every time. Here we are getting the piece of information directly from the health node. This means that if you update the health node and for some reason you change the maximum health property, this is going to break the interface script. So you may want to consider replacing this with yet another signal on the health node, max health change, and to use it to update the interface at the start of the game. So that way you don't access the health node's max health property outside of the health node's script and outside of the player scene. For the last part of this tutorial, we're going to add some animation not only to the gauge, but also to the HP label. Animation that gets triggered when the character takes a hit. We're going to work entirely on the life bar now because we receive the value when the character takes a hit. We have everything we need to create the animation. So open the interface scene followed by the life bar. You're going to work with the script. We have two nodes to handle animation, tween and the animation player. On the animation player, you have a shake animation we're going to use on the HP label. This one is hard-coded. It moves the label from left to right and animates it red. We're going to start the animation every time the health changed, so every time the character took a hit. But we have to modify the code a little bit to accommodate for our tween start. We're going to add a new function to animate the value on our texture progress and on the counter, but we're going to use some kind of range. So we're going to give it a starting and an endpoint. And this function will only contain the animation. So let's call it animate value, and it will take a start and an end value. We're going to call it from the on-interface health change callback because this is when we change the health. And we're going to animate from the current health that we'll have to store to the new health. We have to add a new variable at the top of the script. Current health is going to start at 0. When the health changes, we're going to update the current health to be equal to the new health. Now, because we have both the current health and the health, we can animate the value from the current health, and the endpoint will always be the new health. We're going to remove the line where we change the texture progress value directly to animate it now. In our animate value method, we're going to use the tween node to interpolate our value property on the life gauge. So we have to animate the texture progress node. We're going to pass in the value property. That's the one we want to modify. And then for the initial and final value, we're going to use start and end. For the duration, let's enter something small to start with, 0.3 seconds, for instance. And for the transition type on the demo, I've been using elastic, which will give the animation a little bit of bounciness. I just recommend to pick anything but linear. So you can use any transition that's going to add a bit of easing to your motion. Elastic is really bouncy, and we want it to ease out. This is going to make the animation start straight away and bounce as it lands on the end value. With that, we have to start our tween. We're going to get the tween node again and call it start method. And you can already try your animation in the game. It should work. You get that little bouncy animation on the gauge. Because I'm using the elastic transition, 0.3 seconds is a little too small, so I can increase the value and try again. Unfortunately, there's no way to control the amount of elastic or the amount of transition or easing in Godot at the moment. If it's too much, you just have to use a different easing. Now for the counter, we have to set the value using a string. So we can't interpolate the text property directly. We're going to need a method. Let's create that. We're going to call it setCountText, and we're going to pass in just a value maybe. And I'll cut the line where we edited the count text here. Now we're going to calculate or set the text a little differently. I'm going to use functions directly to build the text. We're going to animate this value with the tween node. The thing is, tween is going to return floating point values. So we may get a very long floating point value. So we're going to round it first. And because we're going to set it on the text property of our number node, we need to convert this value to a string. Then you can use plus to add to a string. We're going to add a /, and we're going to also convert our maximum value to a string. And this way we will get our rounded number as we got before, but we can animate it using the tween node. It's very similar to interpolating a property, except we have to use interpolate method. And we're going to interpolate the method on self as we're using this node's setCountText method. Let's pass it in as a second argument. And the rest of the animation is going to be similar. So you can copy and paste all the parameters, but we're not going to use elastic transition because it's going to make the number value bounce. Instead, we can use something like quartz or exponential to make the number update quickly at first and slow down as it gets closer to the end value. We can also modify the duration for this one. It could be a little faster than our elastic transition. And the last thing we want to do is to play our animation to make the counter look red, the shake animation. But we only want the element to shake when the character takes a hit. If the character gains health, we don't want this red animation. We may want a green healing animation instead. We have our start and end value, so we can check that the end value is lower than the starting value, meaning the character lost health. So in this case, we can get the animation player and play our shake animation. You can try the game now and see all your animations play in parallel. The key takeaway here is that our animation on the UI just takes the values that we got from the health node, it just works with them. We don't change the state of the interface. The animation is a reaction to a change in the interface's state. This tutorial is part of a series of a free stretch goal from my previous Kickstarter. You can find a link to the full series on the screen in the description. And now GDQuest has a Patreon page to help fund more content to keep the channel alive. Please check it out. That said, be creative, have fun, and see you in the next one. Bye-bye.